Dear students, now we are going to do a very important problem under Cauchy's integral formula. This problem is our fourth problem. So carefully watch this problem. The problem here is evaluate integral over C z plus 4 divided by z square plus 2z plus 5 into dz, where C is the circle given by modulus of z plus 1 plus I equal to 2. So now we have to evaluate it using Cauchy's integral formula. So first of all we have to split this denominator. So how to split this denominator? So here I am going to write the solution. So what they have given, z square plus 2z plus 5 is given. If the denominator becomes 0, means the above function will not become analytic at the point where it becomes 0. So we have to find where it is becoming 0. So z square plus 2z plus 5 equal to 0 means we can find z by means of z equal to minus b, that is minus 2 plus or minus root of b square. What is b square? B square is 2 square, it is 4 b square. Okay, minus b plus or minus root of b square minus 4ac, that is 4 into a is 1, 1 into c, that is 20 divided by 2a, which will be 2. Okay, so I shall write here the formula. When the equation is in the format of ax square plus bx plus c equal to 0, then the solution will be x equal to minus b plus or minus root of b square minus 4ac divided by 2a. So by using this formula we are obtaining this. So we get z equal to minus 2 plus or minus 4 minus 20 is minus 16, root of minus 16 is 4i, so plus or minus 4i divided by 2, which implies z equal to minus 1 plus or minus 2i. Now we have to make this denominator in the form of z minus a. So we are writing it as z minus, okay, z minus, it will become, if it is a, it will become z minus a, so minus 1 plus or minus 2i. Okay, now it will imply two factors, that is z minus minus 1 plus 2i, comma z minus minus 1 minus 2i. So these are the two factors of the denominator of this denominator. So we can write integral over c z plus 4 divided by z square plus 2z plus 5 equal to z plus 4 divided by z minus minus 1 plus 2i into z minus minus 1 minus 2i. Okay, but we have to check whether both these 2 points are lying inside the given circle or at least any of the point lying outside. Okay, so for that we want to check that curve equation also. We have to check that curve equation also. Okay, we have to check that curve equation also. So we shall write the curve equation here. What they have given, C is modulus of Z plus 1 plus I equal to 2. Z plus 1 plus I equal to 2. So you have to know there are many ways of finding the circle properly defined to this region. One is we can change it as Z minus C, that is Z minus of minus 1 then minus I. Here real part is minus 1 and imaginary part is also having minus. So x is minus 1, y is minus 1. X is minus 1, y is minus 1 and the radius is 2. So center is minus 1 comma minus 1, radius equal to 2. This is one way. But what is the actual proper way? We can write this Z as x plus iy. X plus iy plus we are having 1 plus I here. So we can write that as 1 plus I more or less equal to 2. So we can combine real and imaginary parts. X plus 1 plus I into y plus 1 equal to 2. For this we are having modulus. So modulus of x plus iy means we will have square root of x square plus y square equal to r, which will become x plus, on squaring on both sides we will get x plus 1 the whole square plus y plus 1 the whole square equal to 2 square, which is the equation of circle. X minus h, which it looks like x minus h the whole square plus y minus k the whole square equal to r square. So here center is minus h equal to 1. So we can write x minus h. Okay, we can write it as, just a minute, we can write it as, we will have center as h comma k. So center is h comma k. I shall bring it little down. Center is h comma k. Okay, center will be h comma k. So here h equal to minus 1, k equal to minus 1, r equal to 2. So center is h comma k equal to center of minus 1 comma minus 1 and r equal to 2. So this is another way of finding the center and radius. This is another way of finding the center and radius. Now we shall draw the circle. Okay, now we shall draw the circle with center minus 1 comma minus 1, which means the real part x part is minus 1, the imaginary part y is also minus 1. Okay, so we shall draw a circle. So I shall first mark the points 0 comma 0, and this point is 1, this point is 2, this point is minus 1, this point is minus 2, this point is 1, and this point is 2, this point is minus 1, and this point is minus 2. Now the center is minus 1 comma minus 1. So this will be our center, and radius is 2. So from minus 1 to radius 2 means you will have the area up to minus 3. You will have up to minus 3 in the fourth quadrant. Okay, so 1 to third quadrant, and you will have minus 1 to 0, 0 to 1, up to 1 in the fourth 1, 2, 3, fourth quadrant, and minus 1, 0, 1 in the second quadrant, and minus 1, minus 2 and minus 3 up to this in the see, we will have these values, okay, again in the same quadrant. Okay, now we are going to connect these points to get the circle. Okay, to connect the, we are getting circle. Okay, assume this is circle. Okay, it will not be look like a circle actually when I am drawing it, but when you draw in a graph sheet with proper scaling, you will get a circle. Okay, now this is x and this is y. Now we have to check what are the points here. The points from z minus of minus 1 comma minus 1 plus 2i is having minus 1 comma 2, and from the points z minus of minus 1 comma minus 1 minus 2i is having the points minus 1 comma minus 2 in x and y axis. See, minus 1 comma minus 2 is lying inside a circle, whereas minus 1 comma 2 is lying outside a circle. This point is minus 1 comma 2, and this point is z equal to minus 1 plus 2i is, this point is minus 1 comma minus 2. So what shall we write from this? We can write z minus a. Okay, so z okay, we shall write z equal to what point? Minus 1 minus 2. So z equal to minus 1 minus 2y. Okay, z equal to minus 1 minus 2, that is z equal to a. That is, this point is lies inside the circle modulus of z minus 1, then minus I equal to 2, whereas z equal to this point minus 1 plus 2, minus 1 plus 2i lies outside the circle modulus of z minus 1 minus I minus 1 minus I equal to 2. Okay, so by Cauchy's integral theorem we have to make the denominator of f of z to be lies inside a circle. Denominator of f of z to be lies inside a circle. So I am going to change denominator. So I am changing it, the function as f of z. Okay, integral over c f of z by z minus a dz to be, see how I am writing, integral over c z plus 4 okay, divided by what lies outside, z equal to minus 1 plus 2y lies outside. So minus 1 plus 2y means z minus 1 plus 2y whole divided by z minus a. What is z minus a? Z minus 1 minus 2y into dz. Okay, so this is what we have now. Okay, done. See, since there are no square or anything having higher powers in z, so we are using simple Cauchy's integral formula. So by Cauchy's integral formula, we know that just a minute, we know that integral over c f of z divided by z minus a dz equal to 2 pi I into f of a. So we have to identify what is a. So what is a here? A equal to minus 1 minus 2y. What is f of z here? F of z equal to, other than this denominator, that is our f of z is z plus 4 divided by z minus 1 plus 2i. Okay, this is our f of z. So now we can write f of a. So f of a equal to minus 1 then minus 2y plus 4 divided by minus 1 minus 2y, okay, minus 1 plus 2y, that is equal, minus 1 plus 4 is 3 minus 2y divided by minus 1 plus 1 become 0, then minus 1 plus 1 becomes 0 and minus 2y will become minus 4i. So we are having 3 minus 2y into 3 minus 2y divided by minus 4i. Okay, so our f of a can be written as f of a equal to minus of 3 minus 2y divided by 4i. So by Cauchy's integral formula, our answer will be, see, I shall write the answer here, but you can copy the answer separately. That is equal to 2 pi I into minus of, see, simply put 2 pi I of minus 3 minus 2y divided by 4i. So both these I will get cancelled and these 4 and 2 will get cancelled. So we get to the answer is minus pi divided by 2 into 3 minus 2y. This is the solution. I have written the solution. Since I am not having any place below, I am writing the answer in the previous step, but you have to write from this to from this separately. Okay. So for understanding, I am writing here the solution is integral over c z plus 4 divided by z minus 1 plus 2y. Okay, or you can simply write the question itself. Okay, in the next step, divided by z minus 1 minus 2y equal to minus pi by 2 into 3 minus 2y, that is that is the question is integral over c. The question is z plus 4 divided by z square plus 2z plus 5 into dz equal to minus pi by 2 into 3 minus 2y. Okay, hence this is the solution. I hope you all understood the problem. This problem is very important. It may be asked in 14 mark also, but most probably you will have it in 7 mark problem, but it is very important problem. Okay, thank you all for watching this problem. Thank you all once again.